Welcome back, guys. Today we've got Eric Lau, and we're going to go deep into the workflow of Geomagic Essentials. Now today we're going to be focusing on Mesh Doctor, and Mesh Doctor is used to clean up the meshes and the scans and whatnot that you import directly, and then also to reconstruct holes and things like that, and really just clean up the scan and make it complete and just make it overall better. So that's Mesh Doctor and Geomagic Essentials, and without further ado, let's bring in Eric and get right into it.
Hey guys, this is Eric from Shining 3D. Thank you so much for that introduction from Vision Miner. And we're just gonna jump right into it. First tool we're gonna look at is the Mesh Doctor tool. And over here, I have this scan data of a Porsche cover, which was originally scanned in 0.1 millimeter point distance. So the first tool that we're gonna look at is the Mesh Doctor tool, which is up here. And it says automatically repairs the imperfections in the polygon mesh. If I click on that, it's going to run through an analysis of the mesh file and all the problems that the software thinks it has. And it's going to tell us exactly what those problems are and tell us exactly what is wrong according to the software. And we're going to be able to see exactly what we can fix. And the software is actually going to automatically help us fix all the imperfections quickly so that we can move on to the alignment to the world plane and then to the extracting features for reverse engineering. All right, so now that the Mesh Doctor tool has finished analyzing the parts, we can go to the left side of the screen here and see exactly what we can fix. So the analysis says 0 non-manifold edges, 37 self-intersections, highly creased edges, 147 spikes, 511, small components, small tunnels, none, and then 13 small holes. And we can cycle through all of them if we go to the walkthrough here, which zooms in on each individual area that the scanner sees there's a problem. And all of these you can't really see with your eye, so it's really helpful for the software to go through it and then give you the automatic option of fixing everything here once we hit the apply button up on top. All right, so now the Mesh Doctor 2 has run its course. As you can see on the left side of the screen here, all of the imperfections that the software detected has now been turned to 0. So we can click OK to accept those changes. And one other thing that I'm going to do right now is I'm going to decimate this a little bit more because it's going to be easier for my computer to work with. So up here in the Scan tab, you'll see the tool Decimate. Click on that, and then it will give us settings to reduce the number of triangles. So right now you can see it's at 10 million triangles, and I don't really need that many triangles to represent this part. And I think I can go down by 50% and still keep the amount of detail that I would want to extract from this. So I'm going to go ahead and reduce it by 50%, click apply so that I have a mesh file with 5 million triangles to work with. And that's going to be a lot easier for me. And now we can go and use the fill hole tool, because if we look around this model now, there are a lot of holes that we should fill to fix the mesh file before we go into extracting features such as using the cross-section tool or extracting the holes and their center points. It would be really helpful if this mesh file is just a little more cleaned up to work with. So we're going to go over to the fill holes function over here and click on fill all. So this one will automatically select all the boundaries that it wants to fill. And as you can see on the left side of the screen, we can set it to deselect holes that we don't want, or ignore complex holes. But for this specific file, what we want to do is fill every hole except for the center, for the hole boundaries around this area, because we want those boundaries when we use the extract feature for circles. it's going to be really helpful for us to still have these boundaries to click on when we use that tool. So I'm going to go around and just deselect the boundary for these holes. And now I'm going to go to the other side and do the same thing. And the tool that I'm using right now is, you can see on the very bottom, is Control left mouse to ignore hole during the filling process. Now you can see all the holes on the parts are now green, and all the holes that we want to fill are red. And so we click apply here, it's going to fill all those red holes with this specific hole filling method of using curvature. Specifies that the new mesh must match the curvature of the surrounding mesh. And then also, this is a complete hole filling method, which specifies that the entire opening will be filled. And we want to click on the edge of the hole to be filled. So there's some other tools here that you'll see that is really good for more complex holes, such as this partial fill, which specifies that a portion of the hole will be filled. And then there's the bridge, which specifies that we will build a bridge across a hole, thus dividing it into separable fillable holes. And this is really helpful for some other parts or some other scan data we might otherwise be unable to fill with the complete hole filling method. And you can see, once I went through that tool, those red areas or red boundaries are now filled as red areas. And they look really good. So we're just going to go ahead and click OK to accept those changes. And I'm also going to show the fill single tool for this specific hole here that was not filled, where, as you can see, if I click, I can change the type of fill method. So there's up above, there's curvature, tangent, which specifies that the new mesh must match the curvature of the surrounding mesh, but with more tapering than curvature. And there's also flat, which specifies that the new mesh is generally flat. So for this one, I'm going to use the tangent method so that the new hole will be more tangent to the surrounding mesh. And that looks really good. So I'm going to click fill single again to accept that change. And now we have a really nice cleaned up mesh file to work with. One more hole that I'm going to fill is over here on the side, and I'm just going to quickly go ahead and click on those and fill it in. And the reason that I'm doing this again is because when I create cross sections from a plane, I don't want those curved data to show that there's a hole there. I want it to just be a straight line, or to be a line going through these areas. All right, so now every hole that I wanted to fill has been filled. And the next thing that I'm going to do is I'm going to start creating my planes so that I can align the data, this mesh file in particular, and then also all the features that I'm going to extract to an origin that I create. And this is going to be really helpful because when I bring it into a CAD program, it's going to appear centered on the origin in that program based on what I select here. So one of the things that I want to show is the selection tools, which, as you can see up here, there's a lot of tabs: Scan tab, Model tab, Tools tab, and then the Select tab, and also the View tab. And if I go to the Select tab and I go to Select Tools and click on these different type of selection methods to help me with this process. And so for creating planes, the best one to use is the Crease Angle tool, as this will adjust the selection based on the angle. So I just click and then I kind of drag it up a little bit, and that's going to fill in all this area you see. And that's going to help me create my best fit plane here, which if I go to the model tab and I go to plane, I can click best fit and click apply after clicking contact feature. I'll click next to save that selection. And then I can also click on the deviation drop-down menu here to see how far this plane deviates from the surface. So you can see here, and according to this heat map, most of these surfaces are within a 0.43 deviation from the plane. And there are some areas around here that deviate a little more, up to 0.736 away from the plane, which is a little farther away. But for this specific part, it doesn't really matter too much. So I'm going to click OK and accept that change and create a feature for the plane there. Then I'm also going to create two other planes to represent my XZ or YZ planes. As the bottom one, the plane one, is going to be our XY plane. So I'll go ahead again and use the crease angle tool to create these other planes. One over here on the side, which I'm going to use for my YZ plane. Okay, there's some dead space here, particularly because it's getting a little hard to click on this file. But instead of using the crease angle, I'm going to go ahead and use the paintbrush tool instead, as this is a little bit simpler for the software to create. So I'm going to go ahead and paint in this area. And that was the control left mouse, which is deselecting my selection. Once I have that plane here, I'm going to go ahead again and create a plane. Click next. This one's going to be plane number 2, and then I'll click OK. And then also one more on the side here, which will be our XZ alignment plane. So now I'm using the lasso tool to create my selection. And try not to occlude any areas that might have some curvature, like around these cylinders here. Now I'm going to go back to the plane tool in the model tab and create another plane over there. Click next. And so that will be plane number 3. And once I have those 3 planes, I only need 3. I prefer 3 for the alignment tool. Align to world tool here, which I'm going to click on. As you can see, there's the XY plane, XZ plane, and YZ plane, and those are the 3 planes that we want to use to align to our plane 1, plane 2, and plane 3 for the proper alignment to the origin. And as you can see, right now, the origin is in some far off place, not related to the model. So we really want to snap that first plane 1 to the XY, create a pair like that. As you can see, it's snapped on over there. And then for the next 2, I'll do the XZ will pair with plane number 3. And then for the YZ, I'm going to pair with plane number 2. And so now you can see that the origin is over here. Right on the model. And when we bring it into a CAD program, it's going to appear in the origin right where we set it. So we're going to click OK to accept that alignment. And now all the features that we create from this model are also going to be aligned to that origin. And that's going to help us a lot when we export the files and then bring it into our CAD program to work with. So we always want to organize the features that we create, which you can see under the Model Manager tab. So there's the scan, there's the features, there's plane 1, plane 2, plane 3, and then there is the coordinate system. And if we go to the Model tab here, all of these tools that we use are going to be saved under this feature list. First one that I'm going to use is the circle tool. So this one over here, as you can read, it says it identifies and assigns a name to a circle, so it can be referenced by analysis, alignment, and trimming tools. I'm going to go over the couple tools that I want to use for this part to extract the design intent is one, the position of the holes, which I'll extract using the circle tool, and then also the point tool to get the center points. And then I'm also going to create a couple more planes for these different faces and use the cross-section tool, create by section under here for free curves, so that I have some wireframe data to use as a reference for my sketches when I bring it into the CAD program. So let's go ahead and go through those tools. First one, circle tool. We're going to, as you can see, there's a couple different ways I can select the circle or create the circle. It's either through the natural boundary or area selection. And the reason that I kept those boundaries on the hole instead of filling them is that so I can use the natural boundary tool here. So if I go over and click on the green area that represents the boundary for the hole, it will automatically create a circle over there. And I can click apply, and then next. So that is circle number 1. And then I'm gonna keep doing that throughout the part and try to keep the naming, the labels as consistent as possible. And also make sure that the holes are as perfect as possible, as these are going to be used when we recreate the parts. It's important that these are accurate. Right, so circle number 4 over there. Move on to the next one. Circle number 5. Click next. Circle number 6. So with these specific holes that came from the scan data, I can use the entire boundary that represents this hole really well. It's working really well in extracting those circle features for the holes. I can also use a partial boundary if the data was not as perfect as this. We really only need, I'd say, a little less than half of the boundary that represents the hole in order to extract the circle. As you can see, we're going through the circle tool to extract all the diameters of the holes and their center position. So I'm going to go through all the holes right now, fast forward, and then we're going to talk about some of the other extraction methods that we can use for this part.
Good times. Thank you guys so much for watching. If you got questions, leave them in the comments down below. We read them all and we really want to help you get the answers to your questions. Now, if you're interested in a scanner or you have specific questions for us, give us a call, shoot us an email. We're always here to help you actually determine the right machine and the right process for your application. Don't hesitate to reach out. We're here to help. We really are. Other than that, make sure you've seen all the videos in this series. We've got different parts from the Mesh Doctor, aligning the world planes, exporting and creating NURBs, etc. And there's a whole series. Make sure you subscribe so you see as the rest of them come out. And as always, thank you so much for watching. Have a positive rest of your day, and we'll see you on the next video.